Oh, hi. Welcome back to my lab. You can sit right over there if you like, but you'll have to put those goggles on. You can actually help me out today because I'm doing all kinds of fun experiments and I need you to write down your data. So you have a sheet like this right in front of you. If you would collect your data on that, that would really help me. So I'll do the experiment and you collect the data. Thanks for putting your goggles on. So I'm going to test different solutions, acids and bases, and we're going to test it with these cool chemicals called acid-base indicators. Acid-base indicators are actually dyes. So a dye, something like this, a colored solution, and you can put it on paper, and something really fun happens is that that paper can change color depending on if it's an acid or base that hits it. So what I'm going to do is I'm going to lay out pieces of paper. I'll hold them up so you can see them. And I'm going to test them with the different solutions. So this paper here is red, as you can see, and this one's blue. It's the same basic dye, but there's two color versions of it. And you're going to learn, you're going to collect the data, make some observations, and you're going to see how different acids or bases affect. So first I'm going to put some acetic acid in this spot plate so I have it available. So acetic acid's in well 1, you'll need to remember that. And then hydrochloric acid, you remember how those two acids are different? And the third one, sodium chloride. So this is salt water. And sodium hydroxide. Sodium hydroxide is a strong base. And lastly, ammonia, aqueous ammonia, which you know is a weak base. Okay, so what I'm going to do to test these is I'm going to take my stirring rod, I'm going to dip it in each solution and test out the different papers. So here's the first one. This was acetic acid. I'm just going to dip my stirring rod to it. You can see. You make the observations. What color did the paper become? Okay. Now let's try the hydrochloric acid. Get a little drop on here. So what color is litmus in acid? You're probably not too excited about those observations. Well, let's try sodium chloride on that same paper. Is sodium chloride an acid? Is it a base? Yeah, you're probably thinking this is not very interesting. Well, let's try the strong base. Look at that. What happens to the litmus paper in basic solution? It goes back to this color. See? And if I wanted to, I can take my acid and make it go back to the red again. See that? It's back to the red. So litmus is a certain color in acid, and a different color in base. So let's try the weak base. There you go. See? Okay, well, what happens if we use blue litmus paper? So we've already seen what acid does to blue. So here I have blue litmus. I'm going to start it with the acetic acid. Can you see what happened? Were you surprised by that, or did you expect that? Okay, that was acetic acid. Let's try hydrochloric acid. See? Okay, you remember what the sodium chloride did to the red litmus paper? What do you think it's going to do to the blue litmus paper? What do you think? Going to keep it the same color, or is it going to change? Let's see. Are you keeping good observations? All right, let's try litmus, blue litmus with sodium hydroxide. What do you think is going to happen? So take a guess. Let's see if you're right. And lastly, we're going to take the aqueous ammonia with blue litmus. You can see what happened. Okay, so litmus is just one kind of indicator. It's only got two colors, blue and red. But I'd like to try a different one. So this is the glassware I have in my lab today. So I'm going to put a little bit of each solution in each of these containers. So in this first beaker, that's acetic acid. Here's hydrochloric acid. Here's sodium chloride. Here's sodium hydroxide. And here's the ammonia. So some indicators are best if they're on paper like this, very simple, but some indicators are better if they are dissolved. And this is phenolphthalein. Right now, you might say it's clear, but that's not a color. We call this colorless. We would call water colorless. So that's an important observation, is that in its normal state in the dropper, it's colorless. So I'm going to add, it's dissolved in alcohol, and it evaporates very easily, and so phenolphthalein is better in solution. So I'm going to put some drops first in the acetic acid. You can see it didn't really change color. Now I'm going to put a drop in the hydrochloric acid. Okay, this was sodium chloride. And here was the sodium hydroxide. Ooh, look at that. So what do you think phenolphthalein's a good indicator for? Here is the ammonia. So how many colors does phenolphthalein have? What color is phenolphthalein in an acid? What color is phenolphthalein in a base? Okay, I'm going to clean up and then I'm going to show you another indicator. Well, there's another indicator. I mean, there's quite a few. Here's one that's really kind of cool. It's called universal indicator, and it's got many different colors. You can put universal indicator on paper, or you can have it in solution form. I tend to think it's more fun in solution form. So I'm going to go ahead and put my same solutions. There's acetic acid, hydrochloric acid, sodium chloride, sodium hydroxide, and ammonia. All right, so now I'm going to put a drop of universal indicator in each of these, and I'll hold it up so you can see it. So that's universal indicator in acid. Make sure you make good observations and write them down. That was acetic acid. Here is hydrochloric acid. Okay, sodium chloride. Do you think it's going to be that same color? Let's see. Okay, what about in our strong base, sodium hydroxide? Ooh, that's pretty. And this is ammonia. What color do you think it's going to be? So universal indicator actually has all the colors of the rainbow. These are stronger, but green is neutral, more purple or blue is towards the basic side. Now maybe right about now you're getting an upset stomach and you're just wondering if it's time for a commercial. So I have this antacid to help you with your upset stomach. And I wanted to put it into a graduated cylinder with universal indicator, just for fun. What's going to happen? What colors do you think it will form? This is one of the reasons why I love chemistry, because of the colors. So let's just plop in and see what happens. Ooh, look at that. Can you see the red, the pink, the orange, the yellow? Yep, it's going to bubble over. Now, why is it more towards the acid side than towards the base side? I hope there's nothing in this desk. So let me get rid of some of that. Yellow is more towards the acid side. Why did it do that? That's because it produced carbon dioxide, as that was the gas that was produced. And carbon dioxide actually reacts with water to form a weak acid. Now what would happen if I put some sodium hydroxide in there, just for fun? Look at that. I just love these colors. Look at it. You can see how it's reacting as it reacts. You can see how it mixes. What What happens if I put a little bit of acid in here? You can see it's going back towards the pink, but then as it mixes with that base, I just love those beautiful colors. All right, I have a couple more experiments to show you after I clean up. Okay, acids react with metals. So I have two acids here. I have a hydrochloric acid and acetic acid, same concentration, 1 molar. Now, you know those are different kinds of acids. So let me put acetic acid and react it with zinc, that's zinc metal, and I want you to observe if these reactions are different. So I'm going to put 20 drops. So there's the acetic acid on the zinc. Now I'm going to do the same thing with the hydrochloric acid, and you observe if they're the same or different. Same number of drops. Can you see what's forming? So now we can see this reaction with sodium carbonate. So I'm going to put hydrochloric acid into this first test tube. I'm going to put 20 drops in. And then I'm going to add acetic acid to this other one. Would you say those reactions were the same or are they slightly different? So you know for chemical reactions to occur, there has to be either a color change or bubbles. So we've seen both of those so far. We haven't seen much heat or light. But now we're going to see if there's a temperature change when I react an acid with a base. So I'm going to put 1 milliliter, which is about 20 drops, of hydrochloric acid in this test tube, and then we'll measure the temperature. Okay? I'm going to let you measure the temperature. Now I'm going to add sodium hydroxide. And we're going to see if there was a reaction as evidenced by a change in temperature. Okay, well, thank you for doing some reactions with me today, acids and bases. I hope you enjoyed it as much as I did. I certainly am happy to have someone come along and collect the data and make all the observations so I don't have to. So you're welcome to come back anytime. Oh, just take the goggles off and leave them right there. Okay, see you later.